Hello, welcome to part 4 discussion of 8086 microprocessor. This topic covers with the physical memory organization concept and special modes of operating for 8086 microprocessor. The points that were focused in the previous discussions went on the concepts like what are the new things, specialties of 8086 microprocessor. Now, if we look over some more things that we generally can't recollect from the earlier processor architecture, saying like we have generalized data and address lines, interrupt lines, clock lines. So some of the lines that bring to our focus in new arrangement here are like this. So test signal is to identify whether the processor is working or busy or not busy. Then we have some known things, status lines. Status lines are indication of the operation that is carried out by 8086 microprocessor, whether it is working on fetch operations, decode operations, or it is working on input operations or output operations. Some of the points that stand in very simple discussion here are S6 and S7 is always 0 for this discussion. S5 is also taken in discussion as 0. So all these three pins have a very less concentration to be made. One of the pin that has some importance here is BHE, bus high enable. This part should be focused in this discussion, and pin number 33, which indicates on minimum mode and maximum mode. So if this discussion is continued with a statement like this, how we actually see our memory is something like this, a rectangle box divided into memory. But what we see here is it's all totally logical. Now we can say like we are using some high-end memories in our computers nowadays, saying like I may say my hard disk is 1 TB. I am purchasing a hard disk of 2 TB. What is this 64 KB in the sense? I have 64,000 locations, which each location holding 8 bits. But you can see this 1T is the location still holding an 8-bit for each capacity. Even if we are using a 64-bit i7 or i5 processor, still the computers are holding 8 bits for each location. How it is this possible is this is carried out through the physical memory organization concept. So how the actual memory division inside the memory support given for 8086 or any other processor will be, it will be in bank format. The banks will be divided in this pattern. First bank will be starting with the 0th address, and the next enhanced version saying like 0, 1 will be in the other address. So if we go on increase the addressing capacities, the count of the banks will also increase. So how it is done here is, if we are selecting the first address, it will be present here. If the next address is selected, it will be present here. And again the next address will be present here. So we can say like all even addresses will be here and all odd addresses will be here based on the data capacity we are having. As it is a 16-bit processor, we divide it into 8 and 8. If it is a 32-bit processor, we will get 2 more banks saying like 8, 8, 8, 8. 0 address, 1 address, 2 address, 3 address. Again 4 will be coming here. If it is a 64-bit processor, we will be having 8 banks like this. Based on each processor data capacity and based on 8-bit strategy, the number of banks will be divided. And based on the number of banks, size of each bank will be equally divided based on the memory we are using. If we are using for 8086 1 MB, then it will be divided equally as it requires 2 memory banks titled as even bank and odd bank. The size of each bank will be 512 KB and 512 KB. This will be the strategy. And this strategy was introduced again newly from physical memory organization concept through 8086. This is why still we are using in our computer memories the name called B. It's not somewhere like W or shown as another format. Now this will be the representation where BHE is a signal that takes the help of first address lines. Always if A0 is 0, it is an even value. So even address, odd address will be represented here. How? If we say 0 is there, we are working on even address. And this is, if it is active low, if it is also 0, we are working on both banks. Complete word is utilized. If address is not even, it is 1. And if this is 0 active low, then we are saying like we are accessing odd location only. And A0 is 0 indicates we are working on even location, and this is isolated. If it is tri-stated, making it as 1, this block is isolated, saying like we are accessing only 8 bits and that too of even bytes. And if both are there, saying like 1 means not even, saying like odd address, and this is also inactive, considering like memory is not used, something else is operated here. So this is the physical memory representation. So again, another part that makes focus in the discussion here is minimum mode and maximum mode, single processor mode and multiprocessor mode. So what is single processor mode and multiprocessor mode is when microprocessor is operating alone on its operations, then we consider it as MN. When it is performing with the help of some support operations, support controllers or support processors, we consider it as max, MX bar. So if pin number 33 is 1, we are in minimum mode. If it is 0, we are in maximum mode. So this representation is given like this. So 8 positions of the architecture will be in different pattern here, saying like pin number 24 to pin number 31 will vary in each mode. Else all other pins in the representation will be in the same pattern. What will be the changes with respect to pin number 24 and pin number 31 in minimum mode and maximum mode? All the things that are shown in red color here are minimum mode representations, and all these blue colored are MX, maximum mode representation. So in detail, if we see how minimum mode pins operate, the 24th pin is interrupt acknowledgement, which is directly linked with interrupt request operations. Then we have address latch enable, which is a strobe signal that is generated at every valid address that is generated by the program. Then as similar as ALE, we will be having DEN. DEN enable signal is to show that the data that we are receiving or transferring is a valid data. This is a strobe signal. Whether we are transmitting data or receiving data can be identified to this position, saying like data transmit or receive. The position of this value in minimum mode is 1, we are transferring the data. Then whether we are transferring it through IO or memory is been identified at pin number 28 to show whether we are working on memory or IO operations. Then if microprocessor is giving, it is writing. If microprocessor is taking, it is reading. The single processor mode has these facilities to do on its own in total. So it is utilizing all the maximum representations as a single processor minimum mode operations. Then we have two special arrangements here, hold and HLDA, mostly used for DMA operations. When a DMA controller requests for the microprocessor to hold its control address and data buses for a direct memory access, microprocessor will provide a acknowledgement saying like positive or negative, some acknowledgement will be given through which the DMA operation is carried out. All these representations here show like microprocessor is working on its own conditions. So this is single processor mode. In continuation to maximum mode, it is termed as multiprocessor mode. How the bits will be represented in this is 24 and 25 are shown as status pins. Status pins, where do we find the status pins? In the architecture we have the 6-byte prefetch queue unit. I should mention the word queue in the sense. These are called as queue status. What is the use of this queue unit? Is we can prefetch. Sometimes we can decode, sometimes we can do. Before decoding, we need to fetch. Before fetching, we can prefetch the instructions. So how many locations can we prefetch? Is 6 locations, 6 bytes. Sometimes we can get only 1 byte instruction, sometimes we can get a 3 byte instructions, or sometimes we can utilize a 2 byte instruction. How the arrangement is shown in this is through the help of queue status lines. If the position in these two values is 0, 0, no operation is done. If the position in these values is 1 and 1, equally the queue is getting filled one after the other. If they are having alternate positions, they will be preferring the first location or clearing of the location. This is the position arrangement. So 0, 0, no operation. 0, 1, first location is loaded. 1, 0 is total arrangement is emptied, and 1, 1 indicates like go on to represent. So if we see the combination here, the combination is described between these two, first and next. This is with respect to this. Do nothing or clear everything. So something like this. So in continuation, we have status lines. As mentioned, 8085 has only 2 status lines, whereas in 8086 we have 8 status lines. This is also one of the example to show how the variation or enhancement with respect to 8085 has happened in 8086. S7, S6, S5 are, as mentioned, are already shown as zeros for us. Then status line representation for S2, S1 and S0 are shown something like this. Here, read and write with respect to these conditions. So this will show whether we are reading memory or IO. If all are 0, we are acknowledging the interrupts. If all are 1, we are doing some passive other operations. So if it is 0, 1, 1 and 1, 0, 0, quite opposite numbers, we are either stopping or we are starting. This is the way we can understand this. Similarly, we have for S3 and S4 in combination, they decide the code segment and extra segment, data segment and memory segment operations, saying like we can go like this. If we are using 0, 0, it is extra segment, and if it is 1, 1, it is data segment. Then if it is 0, 1, SS, and if it is 1, 0, it is code segment. So out of the 8 status lines, 3, 2, and remaining 3 are always 0 with respect to the basic design of 8086. So these are some of the most popular pins that we have for maximum mode of 8086. Apart from this, there is one of the prominent, very funny and easy name lock, saying like microprocessor has logged itself, no inputs, no one can interrupt the microprocessor. So complete interrupts will be hanged, saying like microprocessor buses will not be available to any device for access. In continuation to this, we can see when it is not locked, devices can come approach and access for the buses, request and grant procedure. So if we see all these things with respect to the design, we can see in minimum mode, complete operations are done through microprocessor itself, and in maximum mode, some other devices are joining with microprocessor to carry out the operations. The bus controller example is shown here. So all these things can be shown in a timing diagram, like if a simple memory read operation is performed using minimum mode, how many operations will be highlighted. Clocks will be going on continuously. By generating of the first address, ALU will be generated. After generating of address is over, somewhere data is matched. If the data is matched, we are generating another strobe saying like this is a valid data. And what is that we are intentionally doing here is reading operation. So read row active low, so it is shown in this region, it is reading. What is that we are doing? DT by R bar means we are going for an operation for receive. You can see read signal will exist once we get the data, and data receive operation will start as soon as we initiate the operation. The same thing is done totally through 8086 minimum mode operation. Now we can see when it is a maximum mode, it will take the help of status lines. It will take the help of some other things to perform the same operation. So this is an overview of minimum mode and maximum mode. So that will be the quick overview of all the operating modes and timing representations of 8086. And here we take a theoretical gap for discussion of 8086. Thank you for the session.